15.5 Angle Bisectors and Triangles. Let's review some vocabulary. The first word is angle. The amount of turning between two lines meeting at a common point. If you look at this picture, there are two lines here. Once there is turning, then we have an angle. So the two lines meet at a common point called the vertex. The sides of the angles are the lines that are forming the angle. There are two sides on this angle. The next word is equidistant. This means that items are evenly spaced or they're always the same distance apart. For example, if we're looking at these 3 points, A, B, and C, then if AB is the same distance, if A is the same distance from B and C is the same distance from B, then these two are supposedly equal. They would be marked the same, and so they would be congruent. Perpendicular lines. These are lines that form right angles. As you can see in the picture, these angles A, N, M, and B and M would be congruent. They're also 90-degree angles, and you can see from the picture here that it says AB, which is this line, is perpendicular to MN, which is this line here. And now for our word of the day, angle bisector. If you remember from our previous lesson, we learned that one item gets cut into two pieces, two equal pieces, just like the cookie example. Our one cookie cuts in half. In this case, we would have one angle being cut in half. You can see in this picture, we have 3 angle bisectors. Those are these red lines here. And you can see they're crossing straight through the angle. They're cutting the angle into 2 congruent pieces. That is why these are marked the same. As you can see from your lesson, the Angle Bisector Theorem says that if a point is on the bisector of an angle, that's this point here, C, then C would be equidistant. Remember, that means the same distance from each side. So it would be the same distance from C to A as it would be from C to B. And you can see that here as an example in the math when it's written. If angle APC is congruent to angle BPC, now let me point those out to you. APC, that's this angle here that's marked, and angle BPC, if those two angles measure the same, then you're going to automatically know that AC is going to be equal to BC. AC would equal to BC. Now, let's review what a converse is. The converse of any item or any phrase would be for you to switch the order of the statement. So, this statement starts with the angles and then goes into the segments being congruent. So, again, let's look at that. The angles, these two angles would be congruent, and that means that afterwards you know that these two segments are congruent. The reverse of that would be that if you know that the sides are congruent, these the equidistance from A to C and C to B, these perpendiculars here, if you know that those two are congruent, then you're going to automatically be able to tell me that the angles here are congruent. So in other words, when they give you a problem with the Angle Bisector Theorem, they might just show you measurements here in the angles, showing you those two are equal. And they're going to expect for you to know that these two measures here of the segments are equal. The reverse is true on the converse of the Angle Bisector Theorem. They're going to give you measurements on the segments here, And they're going to expect you to know that these two angles are congruent. So they might give you one of the angle measures, and they expect for you to know that the other one measures exactly the same. When you look at the Incenter Theorem, the angle bisectors of the triangle intersect at a point that is equidistant from the sides of the triangle. Now, what this theorem is telling you is basically this. If you know that this point is the incenter, now remember that the incenter is where all your angle bisectors meet. Now, in the previous lesson, we were looking at where all our perpendicular bisectors were meeting, and that point was called the circumcenter. This point here is called the incenter. That's where all your angle bisectors meet. Now, you see where they're meeting? If the problem tells you that that is the incenter, here is what you will know. You will know then that Px, which is this here, the blue, will equal to Py, which will also be equal to Pz. So all they need to do is tell you that this point here is the incenter, and you will know that all these three will be equal to each other. If one of them is 4, then all of them will be 4. Okay, it's time to get started with some actual problems. If you see on this problem, they're letting you know that VP, which is this measure here, they want you to find it. So you actually know that this line here is the angle bisector. Now, how do I actually know that? I know that because these two angles are marked exactly the same. Now, since those two angles are marked the same, then I know that those two that I just marked are actually congruent. So if WP is 4.9, then so is VP. And so then the answer for this problem would be 4.9. And you can type it like this. VP equals 4.9. Okay, Kevin, you asked for it. You wanted a shout out. Here it is. So this one's a little bit harder, but I know that you're just going to do fine with it. Okay, so I'm looking for the measurement of angle HFJ. That's this angle here. They want me to figure out that angle. Now, you probably already know how much that is, but we have to prove it. So, given that the measurement of angle GFJ is actually 45, then the problem becomes very simple. Now, since I was told that these two are congruent, that means they're equidistant, G and J and G to H are the same measurement, that lets me know that these two angles here are congruent because FG is the angle bisector. Now, I'm sorry that I'm not able to put in the symbols, but here's the answer, and you can put it in symbol form. The measure of angle HFJ, which is the one we are looking for, is going to be 90 degrees because the measurement of angle HFG is 45, and so is the measurement of GFJ, 45 also. Now, if you add those together, 45 plus 45 gives you 90 degrees, and that's the one we were looking for, angle HFJ. Let's do number 13 next. Since I know that these two angles are congruent, I also know that YV will equal to YU. Since I know the actual measures, which are in variables, but I still know what their measures are. This one's 5m minus 3. and this one is 2m plus 9. Now I can substitute, so YV will be this one, 2m plus 9, and YU will be 5m minus 3. The rest of the problem is algebra, so letters to the left and numbers to the right. Take 5m and move it over to the other side, make it negative. Take your positive 9 and move it to the other side, make it negative. As you can see, the 9's will cancel, the 5m's will cancel, and we will be left with negative 3m equals negative 12. Now we're going to divide by negative 3, and that will leave us with m equals 4. Now we're actually not done with this problem, because in this problem they're asking us for the measure of Vy. So if you look here, this is Vy. Now if they asked us for Yu, it would be the same thing. Remember, these two are congruent, so I would have been able to plug it in either here or here, whichever one is easiest. Now I'm actually going to take the 4 and we're going to plug it in for m. Okay, once we plug in our number for m, we get 8 plus 9, and 8 plus 9 is 17. So the measure from V all the way to Y is 17. There you go, Kevin. Okay, Martha, here's one for you. In this problem, we actually need to find the measurement of angle GDF, which is this angle here. We have a measure for it right now, but it's in terms of y, and we need to find out what y is first before we can figure out what that angle will be. Now, I do know that 2.7 and 2.7 here are equal. That means GF is equal to HF. Now, that tells me that DF is actually the angle bisector. Now, if it is an angle bisector, which it is, these two angles are going to be congruent. Now, I have measure for both of them. That means if they are congruent, I can set them equal to each other. And the equation looks like this. Once again, letters to the left, numbers to the right. So I moved the 7 and I made it negative on the other side. Now let's do the same thing with 3 and make it negative on this side. So I'm making the 3 negative onto this side. That will end up canceling these two out, leaving me with negative y equals negative 6. Now, since they're both negative, a negative will change the other side of a negative into a positive. And now we know y. Y is 6. Now I'm going to take that y equals 6 and I am going to plug it in where I need it, which is right here, so that I can find that angle. You can see that I plugged in the 6 for the y. Now I have 6 times 6 plus 3. So that means that 36 plus 3 equals 39. So the measure of angle GDF is equal to 39. Okay, that concludes the problems I was going to work out with you. I hope that helps. Ask me any questions if you need to.